All right, welcome back. This is again for AP Pre-Calc. What we're looking at today is topic 1.2. This today is all about rate of change. First thing, I do not have my good pen for writing on the screen, so you'll just have to bear with me. Some of the work might not be as neat as usual, but you guys should still be able to hear what's happening and everything like that. I'll do my best to make sure it looks good. Biggest thing is rate of change. We learned rate of change is really just the same idea as slope. Okay, it's very, very similar idea. Slope really just defines linear equations, but rate of change or even average rate of change we can look at for any type of function. When you do so, for example, we might have a shape like this or something. The rate of change between 2 points, maybe here and here, I don't have values, but you can still get the idea, is really just drawing a line between them to find the slope. Well, notice if your line's going up, that would be a positive rate of change. If your 2 spots between them go down, that means it is negative rate of change. And one thing we also want to understand is what's happening at a maximum or a minimum. For example, look here. This is the bottom. This is a minimum. Well, at a minimum, you actually have a rate of change of 0. Your graph stops decreasing. It hasn't started increasing at that spot. That spot purely has a rate of change of 0, an instantaneous rate of change. Well, having this idea, what we want to be able to do is we want to be able to find rate of change in a variety of manners. One way that we want to find rate of change is given a function or given a graph. So one thing we talked about in our notes is just what is rate of change formula. Well, let's start with slope formula. Slope formula is just y2 minus y1 over x2 minus x1. Well, in this class, we're going to be using something slightly different. That is your slope formula. We want to find rate of change, and we'll generally be doing that with functions. It takes the same format, but it looks slightly different. What this says is f of b minus f of a all over b minus a, where f is some function and a and b are 2 coordinates on that function. Let's look at an example. One thing I might do is say, okay, here is a graph. This graph, we'll take the one from the notes. The graph goes up here, it turns back around. It looks something like this, where the values in which it crosses, the value it crosses your x-axis here was -4, 0 was the actual coordinate. The intercept here, your y-intercept, get that out of the way. Go away. There it goes. Over here then was the coordinate in the notes 0, 4. Well, if you use your slope formula, you can find this pretty easily using your x's and your y's. But we need to be able to get used to our function notation. Well, a and b, those are really just your x's, x2 and x1. We'll take these 2 coordinates to find the slope or the rate of change between them. We know the x's are -4 and 0. In other words, you might call those 2 values your a and your b. Well, that means the other 2 values, your y values, would be the f of b and the f of a. Those are what is known as the output. Your output is always your y value. Well, knowing that, then I don't really need the x's and the y's. I'm going to use that notation, the function notation we've been talking about, where all I need to do now is just plug into that notation. We take f of b, in other words, the output at the x value b, where that output is 4, but let's set it up completely. So we know that f of 0 is going to give us 4. We know f of negative 4 is going to give us 0. Realize when we first set this in, we're dealing with it in the terms of x values. So the two x values we have, the a and the b value, is f of 0 minus f of negative 4. Same thing on bottom, you take those two values and you have something like this. Well, people's question is then, how did I get the 4 minus 0 on top here? How do I have 4 minus 0? Well, realize f of 0. That is telling me that when you plug in the x value of 0, what y value do you get out? We'll go back over here to the diagram. When we plug in the x value of 0, we get the y value of 4. That's where this value comes in. That is what f of 0 is equal to. The 0 here then is because when we plug in negative 4, f of negative 4. When you plug in negative 4, what is the y value? Well, when you plug in negative 4, you get a y value of 0, again found on our graph. On the bottom then, simplify that, simplify your entire thing, you should get a value of 1. That is the weird thing about this class, is we're getting away from slope formula. We're using the same idea, but now we're using a lot of function notation, which is confusing to understand at first. One thing we also need to be able to do is we need to be able to take a function. For example, if I have this function, f of x equals negative x cubed plus 3x, and I want the rate of change on the interval negative 2 to negative 1. First thing I want you to understand, negative 2 and negative 1, those are both x values. Those are both your inputs. Remember, the inputs in our notation are the a and the b. You can always label those two values a and b. Well, okay, if we start to plug in, we know the b value, the second x value that we're given in our interval is negative 1. We know that f of a, the a value, or the first x value we're given, is negative 2. We can start to plug in. On the bottom, it's negative 1 minus negative 2, again, plugging in. The hard part for a lot of people now is figuring out what these two things are. F of negative 1. Well, realize we have this equation f that we were given originally, f of x. And notice the only two things that change between f of x and f of negative 1 is purely what is inside the parentheses. Originally, there was an x inside the parentheses, but now that x changes to be negative 1. Well, that notation is literally telling you what to do. It says instead of x, we are now changing those to negative 1. So we go to our equation where it's negative x to the third. And instead of x, I change it to negative 1. And as you continue through, it's plus 3. And instead of x, it's negative 1. All you need to do is simplify that. Negative 1 cubed. Negative 1 times negative 1 times negative 1 is negative 1. But there's still a negative in front of it. 3 times negative 1 is negative 3. You can combine that. That'd be a positive 1 minus 3, which is negative 2. Simplify the other part. Simplify f of negative 2, right? That was just f of negative 1. We need f of negative 2 as well. And again, that's found the exact same way, which is just plugging in. Well, once you plug in, simplify it by hand. Negative 2 cubed is negative 8. 3 times negative 2 is negative 6, and just combine your values. That'd be positive 8 minus 6, which is 2. Well, now what we can do is we can plug back into our formula. We said f of negative 1 is negative 2. Plug it in. We said f of negative 2 is positive 2. Plug it in. That entire thing is over -1 minus -2. Combine those, that'd give you a +1 on the bottom. So now all we need to do is just combine this, simplify it. -2 minus 2 over 1 would give you -4. And that should be our final answer. Rate of change, all you have to do is plug into our formula and simplify. The function notation, I understand, is a little weird for some of us, but once we get the hang of it, this is something that we're going to continue to use over and over and over. So it is definitely something we need to get good at. Last thing I want to talk about is one of the problems from our notes. I'm going to go ahead and pull that problem up for us right now. So looking at this problem now, what it says is the figure shows the graph of the function y equals h of x of the following, on which interval is the average rate of change the greatest? Well, remember, rate of change we can think of as just slope. Slope is how fast a line goes up or down. So if I need to know how fast it is on the interval 2 to 3, I'm going to find where on my graph those two spots are. And once I do that, I can make my line going through them. I don't know why it's being kind of stubborn. Make your line going through them, see what your slope would be. That looks like a slope of 0. Okay, so that's probably not going to be very fast. What about between 3 and 5? Well, we already labeled the 3. Here it is for 5. Connect your two dots to see your actual slope, your rate of change. Now it looks negative. 5 to 7, what about that? Find your 2 points, connect your dots. That looks like it is positive. It is increasing. And lastly, 7 to 8. Find where your 2 dots would be and connect them. Well, which of those is the greatest rate of change? 2 of them are negative. 1 of them is 0. So the one that's positive would have to be the greatest one. That would be answer C in this case. There is our 1.2 notes all about rate of change, starting to get that idea down. This is a very, very important topic for pre-calc as well as calculus. So we're going to continue to utilize this quite a bit. So we'll make sure we're continuing to practice it all year long.